So what we have is this, try this one, okay, minus a square, the whole thing, divided by 2, okay, and then there's a beta. Beta is this, previous alpha times 1 minus previous alpha divided by previous alpha square plus new alpha. Okay, so previous alpha square plus new alpha. So now I replace this by beta. Yeah, then which one is faster? Okay, so that means I want to compare this one or beta. So now what? I make a third one. Okay, so method 3. Method 3. That means what? This I call it. So basically, I don't do this. I don't need to do this crazy thing. I just do this simple k minus 1 divided by k plus 3. Yes, and I'll call it F3. This one, I don't have this k, I have this. Okay, I call it Nesterov. Okay. So now I have 3. Now I plot it. This is a new code. Previously I have a plot. I don't care. Now I only plot the time and also always plot the one with the subtracting the f min. So now I have to do this again. So and then I do the same thing here. So I also need to make my f3. Okay, and then okay. So I have t3. This is red. Okay, and then I also have this. Okay, so now I have legend. Legend, I need to change name. Where's my legend? Okay, legend is GD with L, Nesterov. Right, and then quite Paul. Run. This is what I showed you yesterday, right? The red and the blue in the end is similar. This. There's also a conditional number. I'm not going to do it, but now you see, slow, almost the same. Now you see, it's the same. More iteration. Let's say 500. Yeah, I get this. This is exactly what I show here. So this is what we have. Implementation, just what? Yeah, we really implement this. And then what about the other cases? You have even more crazy formula. Then you just implement this crazy formula. What's next? You see this way, go up, right? So now I'm going to make the fourth one. So what's the fourth one? So now, so this is Nesterov, this is Paul. Okay, this one is easier to implement. So now I implement this one. Okay, so Paul with restart. This is time, so I always put it in the end. I don't care. Here's the thing. If my f3 at this k is larger than f3 at the k minus 1, I restart. So this is a simple restart. What does it mean? It means if I see this at this point, I give up acceleration. I just go back to gradient descent. So like this. So what I do, if at this k is larger than the previous one, I do gradient descent. So that means at this case, if I see this f is calculated x, so then my x equal to what? Previous x. So basically this is update, right? So I have the previous update. Okay? And then what? Y is x. I remove the thing. And then what? This number need to change. Because at this point, at this current moment, I have a special k. Okay? Special k. Okay, special k. Is this particular k, right? Then next time, after I finish this, I come back to here. Then this k is wrong. Because if my special k is 20, that means at iteration 21, this is 21. But the restart means this should be 1. So I need to do what? This one actually need to subtract special k. And I call it sum. So what is special k sum? That means in the very beginning, special k sum is 0. You don't subtract anything. And then my special k sum is special k sum plus special k. Okay, now I do this. This means what? This means every time if my k is bigger than the previous one, and also this is important, okay, k has to be larger than 2. Yeah, because if you don't have this, you don't have the previous one. And n, okay. So let's say I do this. Now this is what? Method 3 will start. So 4. So I call it 4, okay, 4, and I call it 4, I call it 4, call it 4, okay, nothing wrong. Now I make another one. So this is the fourth one. So 4, and then I call this, and then I need to make a fourth one. Okay, min f4, okay. Now I copy this. Okay, so this is the fourth one. Then what's next? I go here. Okay, this is the fourth one, and T4. This one is the same. I just have this T4. Okay, done. Everything's done. And now I call the name. This is Paul GDR. Okay, now, okay, for this particular case, it's rubbish. Well, you see, still better than the black one. This is the idea. What's the idea? The idea is, at this time, if we see function value go up, we just ignore, forget everything. So this is the code, okay. This is the Nesterov accelerated gradient descent. So what I do is now I do the blue thing. This is exactly what I do, right? I reject, I go back to simple gradient descent. For us, this is projected gradient descent. And then I just set this to initialize this. And I'm using the Poisson K parameter, so it's not this, but you know the idea, right? Okay, so this is the idea. And sometimes you will get this. So that means what? At this point, it turns out it's very fast. Then the one I just showed you is not. So that means restart is not always the best. Okay, so this is the idea. And then, okay, this is the one I'm doing. So basically, I do the gradient descent, and then I make sure my K, I add up the parameter K to make sure this is correct. Yeah, that's it. And then this is all the thing. So gradient descent with constant step size, that means this is 1 over L, very bad. This is T exact, that means using the best step size you can. Of course, this one is faster than this one. Comparatively, these are all rubbish. This is fast, this is Nesterov, okay? But compared with restart, in some situations, restart is even more good. Yes, so this is the idea. And then when will restart be good? The restart will be good if this thing happen. The idea is, you remember, sometimes the blue can overshoot too much. Then you restart. Think about it. If I'm here, this point, blue go to here. But if I restart, okay, now let me draw it in yellow. So now I'm here. Okay, okay. No. So I'm here, okay, yellow is here. What happened at here? The gradient pointing 90 degrees to here. So if I'm here, the next step will be here. Somewhere here, right? And then, do you remember the geometry? I draw a circle, okay? I draw a circle. That means what? I'm moving along this direction, and then this thing have a what? Level set. It want to touch the smallest level set. That means in this, it should find the smallest point, which will be somewhere here. Okay, so that means if I do gradient descent, give up the Nesterov blue, I go gradient descent, I will probably somewhere here, which is little bit better than the red. Yeah, so in this case, this is faster than this blue. This one, this is the distance between the cross and my yellow point. This is the distance between the cross and yellow point, of course, it's much smaller. This is stupid, okay? So that's why sometimes you do restart is good. That also means what? If that thing didn't happen, restart is not good. Okay? So this is the idea. You see, restart is not always good. This one is restart. And you see the green is actually better, not better, worse than the blue. But still, compared to the black, it's good. These are the remarks.